Welcome back to our course on E3D 4.0 in Unified Engineering. This is video 2, Equipment Modeling. In the previous video, we covered how to get started in E3D and navigate the workspace. In this session, we'll model a simple piece of equipment using primitives as well as catalog components. Along the way, we'll introduce key ideas you'll use throughout equipment modeling, elements and attributes, position and orientation, and how obstruction and representation levels affect what you see. Now let's start looking at some equipment. Before we start modeling equipment, it's important to understand how data is organized in E3D. On the left-hand side of the screen, we have the Model Explorer. Every item you see in this tree is called an element. Elements are the basic building blocks of a project, and each one carries its own set of attributes. Let's take an example. At the top, you'll usually find a site. A site is a type of element. Inside a site, we have one or more zones. A zone is also a type of element, and this is where equipment gets created. In other words, equipment always belongs to a zone, and that zone belongs to a site. Now, every element comes with attributes such as position and orientation. These values define the local coordinate system for that element. So, a site has its own position and orientation. A zone inside that site also has its own position and orientation, but it is defined relative to the site. An equipment under that zone has its own position and orientation, relative to the zone. This hierarchy is what ensures that everything in the project lines up correctly. Let's look at this more closely. If I open the attributes form for a site, you'll see basic fields like its name, function, and description. You'll also see the position and orientation fields. These are especially important because they act as the reference system for everything placed within that site. The same applies to zones and equipment themselves. Each one has its own position and orientation values. This means the whole model is built up step by step, with each element sitting in the right place because of the attributes it inherits and defines. When modeling in E3D, two concepts you'll come across often are obstruction and representation levels. These affect how elements interact with each other, and how they appear in the 3D view. Every primitive has an obstruction setting. If it's set to 2, the primitive participates in a hard obstruction check. If it's set to 1, it participates in a soft obstruction check. And if it's set to 0, the primitive is ignored in obstruction checking. This means the software can tell whether elements clash with each other, and whether that clash is hard, soft, or not checked at all. Next is the representation level, which controls whether or not a primitive is displayed in the current graphical view. Let's open the graphics drawlist form. Here, you'll see the different levels available for display. Right now, the drawlist is set to level 6. That means only primitives whose attributes include level 6 are visible. For example, if a primitive is defined with levels from 0 through 8, it will appear, because 6 falls within that range. Now let's change the drawlist to level 9. You'll notice that some of the equipment disappears, and other items become visible. This is because their attributes are defined to include level 9 instead of level 6. To confirm this, let's select one of the items that just appeared and open its attributes form. Here you can see its level set between 8 and 10, which explains why it shows up at level 9 but not at level 6. In the same form, we can also see its obstruction value as 1, which determines how it participates in clash checks. This combination of obstruction values and representation levels gives you control over both the accuracy of clash detection and the clarity of what is shown on screen. For example, you can work with a simplified view when modeling, and then switch to a more detailed view to check surface areas or additional geometry. We can also control how obstructions are displayed using obstruction visibility or translucency settings. Let's take the cylinder inside equipment D1201 as an example. If we look at its attributes, its representation level is set from 0 to 8. Since our graphics drawlist is currently set to level 9, the cylinder doesn't appear in the view. However, if we adjust the obstruction visibility from off to, say, 75%, the cylinder now becomes partially visible. This is because its obstruction value is set to 2, meaning it participates in hard obstruction checks and can be displayed as translucent. If the obstruction value had been set differently, for example, to 0, then even with visibility at 75%, the cylinder would not be displayed at all. I have cleaned up the view by removing all items, and now that we understand how elements, attributes, and representation work, let's put it all together and create our first piece of equipment. We'll begin by creating a new site. We'll call this TDS site. Next, we will create a new zone and call it TDS zone. Think of the zone as a container. It's where we place the equipment for a specific area of the project. Once the zone is created, we can add our equipment into it. Inside the zone, let's create a new equipment element reboiler. As soon as we click the equipment button in the Create group, the equipment creation form appears. This form allows us to specify exactly where the equipment should be placed in the 3D space. For now, let's place it at the origin point 000. We'll also give this equipment a name, TDS 1301. With the equipment element in place, we can now build up its shape using primitives. Primitives are simple geometric forms, cylinders, cones, spheres, and so on, that combine to form the body of the equipment. Let's start with a cylinder, which will represent the main body of our tank. First, we go into the View ribbon and set the coordinate system to EU. This ensures that the cylinder is created with the correct orientation. Next, we create the cylinder itself. We begin by selecting the center point. Then we enter the diameter, which we set as 835 mm. Finally, we specify the height. This gives us the overall body cylinder of the reboiler. Next, we'll create a few cylindrical plates for our reboiler. A cylinder can be created either through the user interface, or by typing CYLI directly in the viewing area. For the first plate, let's position a cylinder at one side of the main body. We'll set its diameter to 960 mm and its height to 60 mm. Once that's done, we'll create additional copies. With the first cylinder selected, we enter the copy command in the view. We choose a base point on the original cylinder, and then place 3 copies. One 640 mm away, another at the opposite end, and a third placed right next to it. This gives us 3 new cylinders in addition to the original, forming the plates we need. For the third plate that we created, let's make a few adjustments. First, we make sure the plate is selected. Then, we'll reduce its diameter slightly to make it narrower. We'll also adjust the length of the plate, so it's longer than the others. Next, we'll add a dish to this end of the reboiler. From the Create group in the ribbon, we select the dish option. We then set the base point of the dish at the center of the cylinder we just extended. After that, we match the diameter of the dish to the cylinder, so it fits seamlessly. Finally, we define the height of the dish. With that, the dish is now added to the model. Let's go ahead and create a sub-equipment. To do this, we go to the Create panel, and under Equipment, select Sub-equipment. This new element will sit under the main equipment we're working on, and it can contain multiple primitives. For now, we'll just add a single box. We begin by specifying one corner of the box, and then define the opposite corner to set its size. With that, the box is created as part of our sub-equipment. Next, we'll make a copy of this sub-equipment. First, we ensure the sub-equipment is selected. We can do this using the power wheel. Once it's highlighted, we run the copy command. Next, we choose a base point on the original sub-equipment. We then specify the new position. Finally, we place the copy in the new location. This gives us another instance of the same sub-equipment. Now, let's create a nozzle. First, we go to the equipment level. Then, in the Create group, we click on the Nozzle button. This brings up the nozzle creation form. In this form, we'll give the nozzle a name, TDS 1301/NS2. It's generally recommended to name nozzles with the equipment tag as a prefix, so we've followed that convention here. For this example, we'll use 150 pounds ANSI flanges as the specification. We'll keep the bore size to 150 mm. Additionally, we'll set height to 635 mm. Clicking Create generates the nozzle and opens the Modify Nozzle form. At this point, we still need to adjust its position and orientation. We begin by changing the position. Then, under Rotate, we rotate the nozzle 90 degrees about the y-axis. Once that's done, the nozzle is in the correct place and orientation. Next, we want to create a copy of this nozzle, rotated 180 degrees. We begin by selecting the newly created nozzle. Then, we type in the command RO. For the base point, we select the base of the nozzle. After that, we rotate it 180 degrees. With that, we now have a second nozzle, copied and positioned opposite the first one. Now let's update the name of the newly created nozzle. We open the Modify Nozzle form from the Modify group. In the form, we change the name to TDS 1301/NS1. Once that's entered, we click Next to apply the change. Next, let's copy the nozzle NS2 to another location. We'll use the Move command with the Copy option enabled. First, we select the base point on the original nozzle. Then, we set the new position along the reboiler's body. For this copy, we'll place it 835 mm away from the original. This gives us another nozzle correctly positioned along the equipment. Let's now modify the newly created nozzle. We open the Modify Nozzle form. First, we update the name to TDS 1301/N2. Next, we change the type to 300 pounds ANSI flanges and set the bore size to 300 mm. Once those changes are made, we click Next to confirm. The nozzle is now updated with its new properties. Next, we'll create two copies of this larger nozzle. We'll use the Move command and then select the Copy option, just as we've done previously. First, we select a base point on the nozzle. Then, we copy it 2,440 mm along the reboiler. We repeat the same process again. This time placing the copy 4,880 mm along the reboiler. With that, we now have two additional nozzles positioned along the reboiler. We'll now rotate the middle nozzle out of the three larger ones. To do this, we use the RO command. We choose a base point on the nozzle, and then rotate it 180 degrees. This flips the nozzle to face the opposite direction. Now, for the two nozzles we copied, we need to update their names. We begin by opening the Modify Nozzle form and selecting the middle nozzle. In the name field, we enter TDS 1301/N1, and then click Next to confirm the change. The nozzle is now renamed and properly labeled. Next, we select the corner nozzle and open its Modify Nozzle form. This time, we change the name to TDS 1301/N3. Once again, we confirm the change. By renaming these nozzles, we maintain a consistent naming convention across the reboiler. This is important because clear, unique identifiers make it much easier to track, reference, and document each nozzle. That brings us to the end of this session on equipment modeling in E3D design. We covered how elements are structured in unified engineering, looked at attributes like position and orientation, and explored obstruction and representation levels. We then created equipment using primitives, and added, copied, and modified nozzles to build up a simple reboiler equipment. With these basics in place, you now have the foundation to begin equipment modeling. If you found this lesson useful, don't forget to like the video, subscribe to our channel, and follow the playlist to continue learning. Thank you for watching, and see you in the next video.